Alright, this is lesson 19, curve sketching 4, using the second derivative. So we're going to differentiate this. We get y dash equals 6x minus 6. Now as before, we'll let y dash equal 0. So y dash equals 0. That gives 6x minus 6 equals 0. So x equals 1. Alright, so we'll have a stationary point at x equals 1. And the y value here is going to be y equals 3 minus 6 plus 7. So y is going to be equal to 3 minus 6 is minus 3, 7 is 4. So y equals 4. So we'll have 1, y dash equals 0. Now we'll look at 1 minus epsilon, epsilon being a very small positive number, and 1 plus epsilon. Now y dash, taking out 6 as a factor, that's x minus 1. And we can see that when we put 1 minus epsilon here, the 1's go out, and we're simply going to get a minus 6 epsilon. And putting this one here, we're going to get a 6 epsilon. So you can see that the curve gradient is zero, negative, sorry. This is 0, and that is positive, so we'll have a minimum. There's a faster way of doing that, because we can see what's happening here. The first derivative is changing. As we're moving in a positive direction, right, it's going from negative through to positive. So in fact, it's increasing. So look at the second derivative, and we get y double dash is equal to 6. And straight away, that tells me that this is positive, so this must be a minimum. And of course, that saves putting up this table. One word of warning though, with the second derivative, this is fine so long as you can differentiate that easily. But if this becomes a rather difficult thing to differentiate a second time, then the table is a much better way to go. Alright, the second one, we have y equals minus 2x squared minus 4x plus 1. And differentiating that, we get y dash equals minus 4x minus 4. So y dash equals 0. We see minus 4x minus 4 equals 0. 4x equals minus 4. That means x equals negative 1. And y equals minus 2 times minus 1 squared. Minus 4 times minus 1 plus 1, which gives me minus 2 plus 4 plus 1. That's 5. Take away 2 as 3. So we have a stationary point at minus 1, 3. Okay, in the table, minus 1 plus epsilon, and minus 1 minus epsilon. Putting in this first derivative, we take the minus 4 out, becomes x plus 1. Now, when we put in the minus 1 minus epsilon, this will give me a minus epsilon inside here, and a minus gives me a plus, so that's 4 epsilon. That's a 0. And putting the minus 1 in here, we get an epsilon, so it becomes minus 4 epsilon. So this time the curve is increasing, positive gradient, 0, and negative gradient. Again, we can see it's a maximum turning point, and obviously it's concave down. Now, again, a simpler way of doing that, look at the second derivative. Second derivative is equal to minus 4. Second derivative is negative. Okay, therefore, this will be a maximum without using this table, because we can see that as we're moving in this direction, positive direction, we're going from positive 0 to negative, so it's decreasing. So the first derivative we take the rate change to the first derivative, which is the second, it's decreasing, which means it's negative.